မင်္ဂလာပါ Welcome back to Cambridge IGCSE Physics. This is part 3 of our series. Today we are tackling past paper 2, variant 2 from May June 2025. Okay, let's get started. Let's see question number 9. Three energy resources are listed. 1 geothermal, 2 wind, 3 nuclear fuel. Which resources get their energy from the sun? Well, in these questions, we need to choose the resources that get their energy from the sun. နေကနေ energy ကိုရတဲ့ resources တွေကိုရွေးရမှာ Okay? So let's see geothermal energy first. So here we need to know what geothermal energy is. Okay? So geothermal energy is thermal energy that comes from deep inside the earth. So it doesn't relate to the sun. So we don't need to choose number 1. Okay. So let's see number 2, wind energy. Does it originate from the solar energy? I say yes. Okay. So we need to know how wind energy and solar energy relates to each other. Okay. Let me explain a little bit here. This is our sun. Sun radiates energy through the space in all directions. Our earth gets most of the energy from the sun. This is our earth. Earth is rotating about this rotational axis. Okay. So let this line be equator. This hemisphere is northern hemisphere and that one is southern hemisphere. So this is North Pole and that is South Pole. Okay. So our earth is a little bit tilts toward the sun this way. Because of this position, equator gets more solar energy than the poles. Okay. So the air above the equator is hotter than the other regions. You know that hotter air expands and becomes less dense and becomes lighter. So lighter air rises up, creating a low pressure zone behind. So lighter air rises up this way, and that creates a low pressure zone here. The cooler and heavier air from the high pressure zone rushes to the low pressure zone here. That causes wind. So you know that air flows from high pressure zone to low pressure zone. That causes wind. This shows that wind energy actually originates from the solar energy. So I said yes. Okay. So we need to choose number 2. So let's see nuclear fuel. That is, in fact, nuclear energy. Nuclear energy comes from a nucleus of an atom of a radioactive material in the radioactive material during nuclear reaction. So this energy doesn't relate to the sand. So we don't need to choose number 3. So correct answer is 2 only. Okay, T. So I hope this is clear. Okay. Let's see number 10. A symbol of a substance has a shape that is determined by its container. What is possible states of this symbol? Okay, so we need to choose the possible state of the symbol. So is that solid state or liquid state or gaseous state? So let's read again the first statement. A symbol of a substance has a shape. That symbol has a shape. This shape is determined by its container. Okay, very good. So we know that. The shape of the symbols take up the shape of the symbol takes up the shape of the container. So that symbol is in liquid state or gaseous state. Because every liquid, every gas can take up the shape of their container. So the state of the symbol must be gaseous state, liquid state, not solid state. So it is not correct. Gaseous state, liquid state only. Yes, correct. Gaseous state, solid state, no. So incorrect. Solid state, no. Liquid, yes. So incorrect. So correct answer is B. Okay. So let's see question number 11. A stationary smoke particle hit the fast moving nitrogen molecule. Which rule describes the motion of the smoke particle and of the nitrogen molecule after the collisions? Do you see that? After the collision. So after the collisions, the motion of the smoke particles moves or stationary. After the collision, the motion of the nitrogen molecule rebounds or stops. Okay. So I think this question is about Brownian motion. Okay. Brownian motion. You know that? Brownian motion. Okay. Let's draw smoke particle first. So let it be smoke particle. And let this little dot be nitrogen molecule. Okay. So nitrogen molecules hit the smoke particle, right? So nitrogen molecules hit the smoke particle. Nitrogen molecules hit the smoke particles like this. The collections of nitrogen molecule to the smoke particles causes an even collision. The collision is an even collision because no nitrogen molecule hit from this side. So let's 3 nitrogen molecule from this side hit the smoke particles. So this collision is an even collisions. Because of an even collisions, there is a net force on the smoke particle. So the net force points this way. So this is net force on the smoke particle. So according to Newton's second law, the smoke particle will move in the direction of the net force. So after the collision, smoke particles will move, okay, along the direction of the net force. So smoke particle, what happens to the smoke particles after collision? Smoke particle moves, okay. So what happens to the nitrogen molecule? So nitrogen molecules hits the smoke particles and then they rebounds. And then they rebounds, okay? So not stop, rebounds. So correct answer is A. Okay, I hope that is clear. Okay, so let's see question number 12. A bubble of gas rises from the bottom of the lake to the top. Okay, the table shows a reading of gas pressure inside the bubble and volume of the bubble. Okay, the temperature of the water in the lake is constant. The values in the 3 rows of the table are correct, but 1 row is not correct. Which row is not correct? Okay, we need to choose incorrect row. Okay. So let's draw a schematic diagram first. So this is the bottom of the lake. And this is top surface of the lake. And bubble of the gas is here. This bubble rises up to the top. Okay. The table shows the pressures and volume of the gas in the bubble at various positions. But 1 row is not correct. 3 row is correct. So how to choose incorrect row? Here we need to understand the behavior of gases. Okay. So you see that temperature of water in the lake is constant, which means the temperature of the gas inside the bubble is constant. So temperature of gas inside the bubble is constant as well because the bubble is in the water. So temperature is constant. Then how gaseous volume and gaseous pressure relates to each other. So if temperature of the gas is constant, the volume of the gas is inversely proportional to its pressure. So volume and pressure relates inversely. Okay. So let's rewrite this expression again. So we can write like this. V is equal to constant multiply 1 over P. So if you change varies to equal, you need to multiply with a constant like this. And multiplying on both sides with P, we get PV is equal to constant. So the gas inside the bubble obey this relation, must obey this relation. The pressure of the gas inside the bubble and the volume of the gas inside the bubble. If you multiply these, you will get a constant. So temperature constant gas must obey this relation. Okay. Pressure times volume always give a constant. So if if we cannot get a constant, pressure or volume, something is wrong. Okay. So pressure wrong or volume wrong. Okay. So let's check first row A. So pressure is 360 and volume is 2.4. So when we multiply pressure and volume, what we get? So let's see here. 360 times 2.4. So we get 864. And let's see second row. So row B. 270 times 3.2. Oh, they produce 864 again. So let's see row C. So 160 times 4.6. So which gives 737. Oh my God. TV, no? So let's see row number D. 120 times 7.2, which gives 864. Okay, very good. So row A, row B, row C always give a constant 864, but row C doesn't. So incorrect row is C. So correct answer must be C. So understand this? I hope this is clear. 70 minutes. Okay. So Dima Yalaime, we shall stop our lesson here and see you next video. Okay, bye-bye.